Good. Right. Well, yeah. In fact, it seems to be it seems to have turned into the year of IXML, as I will explain tomorrow. There are 2 talks on IXML tomorrow, but there've been very many at the at conferences this year. So that's one of the reasons why I thought it'd be worth giving the introductory tutorial again. It's a method for discovering structure in textual documents and delivering that as XML. If you go to this link, cwi.nl/Stevens/IXML/tutorial, you can follow along, and that tells you how to run the examples. It's easier than the XForms version because it just runs in the browser. And similarly to the XForms tutorial, if we don't finish today, although I will zip through this and probably jump over some of the, skip some of the exercises, but I've got an hour, so I'll try and do as much as possible. But if we don't finish everything, you can still self-study it when you get home. And there's also a video which was indeed the one when I was hospitalized and still gave the tutorial from my hospital bed. So how does it work? You have one or more documents in some textual format or another. You supply a description of that format that includes how it should be converted to XML, and the XML processor then uses the description to read and convert the documents. So, just to give you an example, let's take dates. Now, it's clearly got an implicit structure, 7th of November 2024, so let's describe this. A date is a day, a month, and a year. Then we describe the parts, so a day is a digit or 2 digits, where a digit is one of these literal characters from 0 to 9. You'll see a way of doing this in a better way shortly. You can literals can be single or double quoted, has the same effect. And then the month is just a list of 12 possible months, and finally a year is 4 digits. There's one thing missing though there. I said a date is a day, a month, and a year, but you have to include the spaces, the literal spaces between them. You have to describe absolutely everything. So a date is a day, a space, a month, a space, and a year. So if you run this through the IXML processor, this is what you get out. You get absolutely everything that it found tagged within elements. So just to do this, just to start off, do this yourself. So you open the in-browser IXML processor, which is linked from that link I gave you. You copy and paste the required bits of IXML into the grammar field. Then you type something into the input field, click go, and out should come a piece of XML that represents that structure. You have to be aware that the first rule has to be the top level rule. So in this case, date. So you can't put digit first. You have to put date first because that's how it tells it that that's the top rule. And you must make sure there's no new line at the end of the input because that's not in the description. So it would complain that you've got an extra character at the end. So that should only take you a couple of minutes. So go. Don't close the IXML processor window after you've finished because you'll be able to. The next exercise will just be the same. Well, a bit of variation on that one. So don't throw it away. Okay, so if everything went all right, you should have an output that looks like that. Now the thing is, we don't really care about that digit. We only care about the day, month, and year. But that's all right. We can change. We can control how the serialization is done. And if we put a minus before the word digit in the rule for digit, then it doesn't turn up in the output anymore. So if you do that quickly now. And that should only take you a few seconds, just change the digit to minus digit, then you'll see that the result of running that is what is visible here. So do that. Are we good? Yeah. All right, so that's one part of serialization. The other part is that you can make things as attributes as well as elements. So for instance, if you change at year, if you change the year rule so it says at year, then that year will turn up as an attribute. So do that. And in fact, experiment a bit. Make them all attributes, in fact. All right, so if it went well, you should have something like that, which is not an empty element. And why is that? It's because all the input ends up in the output unless you do something different. And in this case, we've got two spaces left over, and so they've ended up in the element. So if you want to get rid of those, you put minuses before the spaces, and they don't turn up in the output. So do that. Yeah, are we good? That should only take a few seconds.
Where were the spaces in the previous output?
Yeah, sorry.
Where were the spaces in the previous output? In the indentation?
The previous output, which was here, they'll be after the day.
So they're in the
after
indentation.
the month.
They're in the indentation.
Yeah, they're actually after the day and the month. So if we'd used slashes, then they would have been visible. Okay, right, let's move on. We've got a day as a digit or a digit, comma digit, but as you might expect, you could put a question mark to make something optional. So you can say a day is a digit followed by an optional digit. So now make that change and try it with both ways round. So make the first one optional and then make the second one optional and see if there's any difference. Well, I can tell you, there is no difference. Yeah, we good? We're really roaring through this. We'll be done in time. Okay, so you could make the year optional like this, but the problem with this is that the space is then not optional. So if you want to make that space optional, you could make a separate rule like optional year, which contains the space and the year, but better is just to do grouping like this, so you put brackets around the bit that's optional. The thing to note about this is that if you do it this way, and we'll see a different way of doing a similar thing later, if you do it this way, then nothing comes out. If there's no year in the input, then there's no year in the output. But we shall shortly see a way of getting an empty year in the output as an option. You can quickly do this. If you wanted to make the year either a 2-digit number or a 4-digit number, you could do it with this way, but just quickly do it with grouping instead now. Yeah, we good? Yeah, so a sample answer is, I've now, from this point onwards, give examples of the answers. So you can just put brackets around the second 2 digits and make that optional, so that you've either got 2 digits or 4 digits. Okay, if you add a plus after something, anything actually, any item, it means one or more of those things, and adding a star means 0 or more. So for instance here, a day, 1 or more spaces, a month, 1 or more spaces, a year. And we could also then say, well, a date is 0 or more spaces, and then the day, and then 1 or more spaces the month, 1 or more spaces the year. You could achieve the same effect by saying, well, S is any number of spaces, except that before a day, it's optional. So that would have the same effect. And you can allow any number of dates in your input by saying dates is date plus. So do this just to see how it works, and that means that on one line, because we haven't dealt with new lines yet, you can have several dates after each other. Yes.
Do we need the minus sign both sides of the colon?
I beg your pardon?
Do we need the hyphen at both sides?
Well, so at the top rule here,
Yeah.
that says the S doesn't appear in the serialization, and the second one means that the space doesn't appear in the serialization. Is that your question?
Yeah, so do we need them both, or can we just have the first minus?
Oh, the first minus means that the tags don't appear, and the second one means that the actual literal doesn't appear. But if you left out the second minus, then the spaces would still appear in the output.
Okay.
It's only the tags that are excluded by that first minus. So before a terminal, it means no tags, and before a non-terminal, like S, means don't include the tags, and before a terminal, it means don't include this terminal. Okay, so now we're getting a bit more complicated. So there are huge numbers of Unicode characters. You can include any one of the characters in a literal string except control characters, since they're non-visible. But occasionally, it's useful to be able to be explicit which character is intended, if they're not visibly different, or if you want to recognize a control character on the input. For instance, a tab is #9, a non-breaking space is #A0. So you could say a space is either a space or a tab or a non-breaking space. So in this case, they all match a single character in the input. So an encoded character represents just a single character in the input. You can't include them inside strings. You don't need to. If you had quotes #A0, that would match with the three characters #A and 0. So a new line is /A or #A or #D. Most operating systems use #A. Windows use #D, #A. So now add to that dates, multiple dates example, allow new lines between dates. Okay? Question? Here, this microphone.
No, I have one.
Oh.
I have an error. No production rules for non-terminals.
No production rules on non-terminals.
So I put dates on top.
Yeah.
And it says...
Grammar failure. No production rules for non-terminals days. So you...
Oh, days. Okay.
Days that you've
okay.
got.
I misread it as dates. Yeah. Thank you.
Are we good? All right, so now we get on to character sets. So I promised a shorthand rule for digit, and that's just with square brackets 0 to 9. But in fact, within the square brackets, you can put several of those ranges, like A to Z, and capital A to capital Z, or a string, or a mixture of strings, or encoded characters as well. So a character set always just matches a single character in the input, although of course you can always put a star or a plus after it, but the actual character set only recognizes a single character. And similarly, you can use a tilde before a character set to mean any character except what's in the set. So for instance, if you wanted to define a string, you would say it begins with a quote, a double quote, and then any number of characters that aren't a double quote, and then another double quote. Yeah. And there's one other thing to note is that since just an empty character set doesn't match anything, then tilde empty character set matches exactly one single character, whatever it is. So now a real exercise. So write a description of a list of strings separated by spaces. So for instance, if you've got this, now is the time and an empty string, then you will get 4 sub-elements out, now is the time, and then an empty string. Okay? Yes, question?
On the previous slide.
On the previous slide?
Oh, sorry. One more, I guess.
Uh-huh.
Okay. Is there an equivalent to an exception, as in regex?
An exception?
Can I do a character class but except?
Yeah, that. Tilde.
I meant inside. Inside the class definition.
No.
Inside the square brackets, is there a
No.
availability of tilde?
The square brackets creates a set, and if you want...
Right, okay, no, well, my question was, like, if I had, quote, A to F, or no, if I had A dash Z, could I have a semicolon tilde G?
No, not within the set. No,
Okay.
no. There's a quote missing? Oh, thank you, yes, you're right. I'll fix that, thank you. Yes, let me get them. Oh, you've got a microphone, haven't you?
I'm trying to use the tilde on...
For the strings, yeah?
well, it's not possible to say a quote is this set, and then I use tilde quote to say I want anything but a quote.
No, the tilde goes exactly only in front of the set, not in front of a name.
No, so you can't deny the name.
No,
or,
no.
Sadly.
Okay, I'm going to move on. Oh yeah, another question, sorry.
No, it's not a question. It's a reaction on Peter. So you can do the negative, you can, if you do it as a separate thing, like no quote or not quote.
Yeah.
You can store that and use that.
Yeah, okay. All right, so this is what a possible solution looks like. Strings is a string, and then followed by 0 or more spaces and a string. Where a string is just the quote, and then a number of characters star, and the character is a non-quote. And spaces is just 0 or more spaces. We'll see a way of doing this differently shortly. Character classes are very handy. There are a huge number of Unicode characters, many thousands, 144,000 plus. And Unicode classifies those characters in different ways, and IXML actually uses the Unicode classifications, but they're only used in character sets. For instance, the class LL, capital L, little l, covers lowercase letters, and capital L, lowercase u are uppercase letters, and class just capital L covers all characters that are considered letters. And in fact, most of Unicode are letters, 130,000 plus of those 144,000 are letters. So you could define a name as just being the character class L 1 or more times. Similarly, capital ND, it covers decimal number characters, decimal digit characters. So you could define a number as ND plus. And there are a couple of other there are quite a lot of character classes. Not all of them are useful, but P is any punctuation. Capital ZS is anything that counts as a space character, but doesn't include tab or new line, which are considered control characters. And SC for any currency symbol. So let's try this. Make an IXML description that accepts a number of lines, and each line contains a name and an amount of money where you include a character sign for the currency. So I'll leave this up, but yeah, each line, a name and an amount of money. Well, so let me show you, exercise, sample answer. So amounts or lines is just person star, where a person is a name, some space, an amount, and new line. and a name is just L+. Spaces are ZS and tab, one or more. And then the amount is currency, a number of digits, either, so I've gone the extra mile here and done both European and Anglo-Saxon numbers, so either a point or a comma, followed by 0 or more digits. And that whole section is optional. Currency, I've made an attribute, and that's just a currency symbol, and a new line is any number of A's and D's. Is that all clear? Is that? All right, so now there's another form of repetition where you can specify separators. So we've already seen 0 or more with a star and 1 or more with a plus. And separators specify what comes between each repetition. For example, a list of numbers separated by commas could look like that. So plus plus and then something, and that something comes between each repetition. If we wanted to separate the numbers by commas and spaces, then you could say plus plus, comma, followed by any number of spaces. And of course, that works with the star star as well. Anything can follow the plus plus and the star star. So a rule name, a group, a literal, a character set, anything that's possible in a rule can follow the plus plus. How are we doing for time? Another 20 minutes. I think I'll jump over this example. So this was going to just change the previous example so that instead of spaces, strings are now separated by commas and spaces, so that now is the time would produce the same output, but we've got different input. And so here I've just got a string star star and then comma spaces. So it's a fairly simple example. So this is what I promised earlier. Apart from using question mark, you can specify something's optional in a different way. And this might not be very visible here, but here we've got an empty alternative. So this says a year is either 4 digits or nothing at all. But if you wanted to make it more obvious, then you could actually say that empty and then give a rule for empty, which is literally empty. So this means that you accept either 4 digits or nothing at all for the year. But the difference here is that if you supply a date without a year, you get an empty year element, whereas in the previous example, you didn't get the year element at all. So, so you've got the option of either saying, don't give me the year element, or give me an empty year element. 19 minutes. I think I'd like to get through all of this, so I'm not going to give you all of these examples, so I'll leave this one as well. This was to define an email address so that its structure is revealed. So, for instance, email is user@host. I've made it very simple and said the user is anything but an @ several times, and a host is a number of domains separated by full stop, and that's actually part of the definition of a domain URL, that the full stop can only be a separator. You can't have it at either end. So this is one example where separators, repetition with separators is useful. And a domain is just any number of letters or digits. Okay, so one of the principal purpose of IXML is to convert non-XML formats into XML so that it can be part of the XML toolchain. And it wasn't primarily in order to check that the input is correct. For instance, the date format that I gave earlier will accept input like 0 January 2021 or the 99th of December 9876. And if you know that the input is already correct, if you only want to convert them into XML, then you don't have to check. But there are some cases where you would like to check that the input is correct. And so if you want to do that, then we have to tighten up the definition by excluding 0 as a single digit and only allowing 2-digit numbers up to 31. So for instance, a day is an optional 0 followed by any digit that's not a 0, or 1 or 2 followed by a digit, or 30 or 31. Again, I'm not going to do this exercise because we've got 15 minutes left and I'd like to get through everything. But anyway, you can try this out for checking dates. And if you want, you can go that extra mile for checking months that can be 30 days long and months that can be 31. So here's an example. What I've done is, I've already shown you the rule for day. And this will then only allow dates through that are feasible. Let's put it like that. Now, I want to get on to some more advanced examples, which is why I'm sort of rushing through this a bit. But let's add ISO dates to the format so that now we both accept a day as spaces a month, a spaces a year, or an ISO date, where the ISO date is a year dash numerical month dashed day. So a numerical month is just 2 digits. So now the IXML accepts both sorts of dates, so it can recognize the one or the other. And for ISO dates, we get it in the form of date ISO. And if I'd put a minus before that ISO, then it would just say date, year, numerical month, day. I'm not going to do this exercise either, but this is the format used by the web protocol, HTTP, for dates. And they always have this format. So if I was going to recognize that, then it would be a weekday, which is one of the 3-letter weekdays, a comma, a day, which is 2 digits, a space, a month, which is one of the 3-letter days, month names, a space and a year, which is 4 digits, and then a time, which is hours, minutes, and seconds separated by colons. But anyway, I won't ask you to do that, but you've seen it, because I want to get onto ambiguity. So let's start afresh, and say a date is a day / month / year. And you can see that I've deleted the slashes there, and I'm specified that a day is only up from 1 to 31, and a month similarly is 0, 1 to 12. Now, the US writes dates with the month first, whereas Europe with the day first. So if we add those two, so we have a date is either the US format or the world format, and the world format is day, month, year, and the US is month, day, year, then if we give it 31/12/1999, we will get a world date that says the day is 31, the month is 12, and the year is 1999. If we give it 12/31/1999, it will say it's a US date with the month 12, a day 31, and a year 1999. But what happens if we give it today's date, 7/11/2024? Well, what happens is that the IXML processor recognizes this as ambiguous, and so it says that in the result it gives you, but gives you one of the answers. So in other words, if it finds an ambiguous parse of the input, then it will still give you something you can use, but it will warn you that there were other possible interpretations that maybe you didn't want. Yeah, well, I've just said all that. 13 minutes to go. I will leave you to do these exercises at home just so we get through everything today. So there are 2 reasons you can get ambiguity. One, inherent ambiguity, like the example that I just gave you, where the data is ambiguous in itself. But sometimes you might make a mistake in how you describe the format. And here's an example. If you say that you've got a number of dates, and the dates can both start and end with spaces, then if you give it 2 dates separated by spaces, then IXML doesn't know whether to take those spaces between the 2 as ending the first one or starting the second one, or a bit of both. So even in this case, it will describe it as ambiguous, because it is, because you've described it ambiguously, and it doesn't know which of those two interpretations to use. Now, it is true, because I've deleted all the spaces, that in both ambiguous cases, the output would be identical. But IXML doesn't know that, and in fact, to check it would take too much time. So it would just warns you that your grammar in this case is ambiguous, and that you should fix it. So in this case, you have to decide whether you want spaces before or after a date. After would be a better choice, and then just have spaces right at the beginning. So dates spaces date plus, and then each date being day, month, year, followed by spaces, and then that would solve it, and it wouldn't be ambiguous anymore. Similarly, if you defined an expression as a number, or as an expression with an operator and an expression with operators plus, minus, times, or whatever, then if I gave you a 1 plus 2 plus 3, IXML doesn't know if that's 1 plus 2 plus 3 or 1 plus 2 plus 3, because both are possible. So again, it will report it as ambiguous. 10 minutes ago, I'm not going to ask you to do this, but you can rewrite the example, the previous example with the dates, where it says it's ambiguous, where you specify that you either get a world date, a US date, or an ambiguous date, like this. So that the output wouldn't be complained of as being ambiguous, but you would get a value that says ambiguous. And how you do that? Well, we have now US, world, and ambiguous dates. World and US both have their day, month, and year. But if a day above 12 for the day is unambiguous. So if you've got a number that's 13 or higher, then we know it must be a day. But if you've got two that are both up to 12, then it's ambiguous. And so so ambiguous is the day-month version, day-month, year, where you can't distinguish between the two. And a day-month is the same as a month. It's any number up to 12. Now, IXML can only describe context-free languages, and I'm not going to define context-free languages, but for example, in the programming language Fortran, strings weren't with quotes around them, but you had to actually say how long the string was. So 6H string was how you defined a string in Fortran. How they came upon that, I have no idea. But it was horrible to use, because you had to count all the characters in your strings. And if you changed it, you had to make sure that you got the number right. But anyway, you can't describe that in a general way using IXML because it's not context-free. You can describe it for a number of cases. So I could say, well, 1H and a single character is a string, 2H and 2 single characters is a string, and so on. But of course, there's a limit to that. Luckily, most languages nowadays are designed to be context-free. And as I just pointed out with Fortran, it's possible to define it for a limited number of cases. By limited, I mean up to a certain number of cases. Again, with 8 minutes to go, I'm not going to ask you to do this, but for instance, nested lists where the list is indicated, the nesting indicates where, how deep it's nested, is not doable in a general way, that is to say to an infinite depth, or an unbounded depth at least, but you can describe this to a limited depth, say to depth 10 or something. So you could then generate something with nested lists. And again, in the tutorial, you can see these answers. Overrides, we've already seen that you can hide an element by doing a minus in front of the element name, or as an attribute by doing an at before the name. And of course, the default is for it to be produced as a regular element. But you can override these defaults when you use a rule. So for instance, here, at the bottom here, I've said, well, start has the format of a date, but I don't want you to output it as a date. So start will then come out looking like a date, but the element's name will be start. And similarly for end, we've overridden the fact that date could come out as an element, and we said, don't produce it as an element, just produce the content. So that I would get this sort of format with a single date, but if I do it as a range, then I get start and end instead of the date. So here I'm just overriding the default of the rule for date. And similarly, so this is a rule you need to know. The root element, you can make the root element hidden as long as its resulting content is a single element, because XML demands a single element at the root. So if I said data is either a date or a range, but I've excluded data, then I will either get an element called range or an element called date out. Yes, question.
Is that constraint of one element on the way out tripping an error, or is it just that you have data that can only be used as an external entity? I don't believe that the specification of IXML says that it has to be checked. It just says it's the author's responsibility to ensure it happens. So I could probably use it to create an external entity
Yeah.
that could be, okay.
Yeah. Right. And similarly, if you want to override a hidden rule, like in this first example here, where digit is hidden, if you do a cap before it, then it'll be output as an element regardless. Yeah. 4 minutes to go. And similarly, you can override at. So if you want something just in one particular case to be done as an attribute rather than in general case, then you can put it on the right-hand side of the rule. This is the last thing you need to know, so I am just going to manage it. All output characters up to now have come from the input, but you can add extra characters by putting a plus before a string or an encoding. So for instance, if you've got this input, 100, 200, brackets 300, 400, where the brackets 300 means negative 300, as in financial reports, then what I'm doing here is, in the negative case, I'm recognizing that it's got brackets around it. I'm deleting the brackets, and I'm adding a minus, so that then on the output, I will get this sort of output, so that I've converted it into pluses and minuses by deleting the input characters and adding some output characters. The end. Right, with 3 minutes to go. Phew. So now that you've seen all of IXML, you might want to marvel at the IXML definition of IXML because it's defined in itself. So for instance, a rule is a mark followed by spaces, and that's optional, and then a name, and then spaces, and then either an equals or a colon, and then spaces, and then a number of alternatives, and a full stop. And of course, this rule is now defining itself. Okay, any questions in the last 2 minutes? I'll be giving another talk. I'll be giving a talk with a larger example tomorrow about using IXML and XForms together to create a banking application. All right, thanks very much.
Thanks very much, Stephen.